Good morning, everybody. Today I am starting a new chapter, that is thermodynamic processes of perfect gases. So before we go for that, first let me read out the chapter's serial number. First we have completed a fundamental and laws of thermodynamics. Okay, so this is a successfully completed chapter, and afterwards second one is laws of perfect gases. So it was for 8 hours chapter, and the third chapter is thermodynamic processes on gases. So in this very important things are, we have to concentrate on some thermodynamic processes. So we know that the thermodynamic processes are around 6 to 7, 8 are there. So among these we can concentrate on only 3 to 4 thermodynamic processes. So in all these thermodynamic processes, we have to concentrate on pressure, volume, temperature relationship, heat expression for heat supplied, internal energy, work done, as well as enthalpy. So I have told you about the general equations of heat supplied and internal energy, work done, as well as pressure, volume, temperature, and enthalpy, the basic explanation. So in this particular third chapter, thermodynamic processes on gases, we will discuss on introduction to thermodynamic process. See, in this thermodynamic process introduction, first we have to concentrate on what do you mean by thermodynamic process. In the first chapter, that is on the fundamentals of a thermodynamic system, I told you about the thermodynamic process, that is thermodynamic state, thermodynamic process, thermodynamic cycle, all this I explained you. Again let me explain the definition of a thermodynamic process once again. See, as you know that thermodynamic process means it is continuous from one starting point to the point where it ends, so that we can call it as a process. Where thermodynamic, the term thermodynamic, wherever the term thermodynamic comes, at the time we have to concentrate on the energy possessed by the gases and vapors. So the definition of a thermodynamic process, you can watch this. You can watch this definition of a PDF of R.S. Kurmi textbook. When a system changes its state from one equilibrium state to the another equilibrium state, then the path of successive states through which the system has passed is called as thermodynamic process. As I said, suppose if the students are coming from their home place or home to the college, then it is a process. Starting point is, I can consider it as one equilibrium state. So you are coming from one place to the another equilibrium state. Another equilibrium state is our college. So the successive path, the path of successive states through which the system has passed. If you are coming from your home to the college, the path which you are following, then that if you plot a graph, then we are getting one graph, then it is called as a process. If for our thermodynamic states and thermodynamic system also, look at this, the sketch, it clearly explains you. When we plot a graph of pressure versus volume, when a system is moving from the point 1, so let me show you the cursor, state 1, it is a thermodynamic state, and when the system is moving from one thermodynamic state to the final thermodynamic state, then the plot, when we plot a graph of pressure versus volume, small displacement of a piston which is plotted by considering the pressure and volume, and when we join all these intermittent points, then we are getting this graph, or we are getting this arc of length, then this is called as a thermodynamic process. So we can say that it is called as a thermodynamic process, and it is considered based on the thermodynamic properties such as pressure, volume, and temperature. See, afterwards we have to concentrate on what do you mean by reversible process and irreversible process. Here reversible process is one where what happens in this figure, you can concentrate. When we plot a graph of pressure versus volume, this is a graph which we obtained. So reversible, when do we say that it is reversible? During the returning of the piston. See here in this the piston is moving from bottom dead center to the top dead center to make a process 1 to 2. Okay, in the same way, during the returning of the piston from 2 to 1, if the same path is followed by the system, If the same path is followed by the system, then it is called as a reversible process. Reversible process means if it is following the same path, the system through which it has passed through, then it is called as a reversible process. Look at the definition which is given. If the process is assumed to take place sufficiently slowly so that deviation of the properties of the intermediate state is infinitesimally small, and every state passed through by the system will be in equilibrium. Okay, it means when the system has moved from one place to the another, and during the return process every state passed through by the system, if it is the same, then we can call it as a what? Reversible process. And if irreversible process is there, then you can see the definition. If the process takes place in such a manner that the properties of intermediate states are not in equilibrium condition, I mean except the initial and final state. So it may vary from 1 to 2, I mean 2 to 1 during the returning process of the piston. What may happen? The system may follow this path, or it may go like this, or it may go like this, or some other points through which it may go back to the initial starting position. Then it is called as a irreversible process. And afterwards we have to concentrate on the classification of thermodynamic processes. See here, in the reversible process and irreversible, I will give the clear definition and this sketch also. You just concentrate on the definition. After that, the classification of a thermodynamic process is very important. Thermodynamic process, in this please concentrate. There are only two main types or two groups, non-flow process and flow processes. Okay, so in this flow processes, what happens? The flow of the system, the flow of the material is taking place. I mean mass and energy are going out of the system. You can see this. It's normally taking place in open system. The process occurring in open system which permit the transfer of mass and energy from the system. Here what happens? Both mass and energy are crossing the boundary limits. Then it is normally flow process. Flow process is normally taking place in open system. And non-flow process, what do you mean by non-flow process? It normally takes place in a closed system. You can see this. The process occurring in a closed system which do not permit the transfer of mass across the boundary. So if a mass is not transferring, only energy can transfer, means it can happen only in a closed system. Then such a process is called as a non-flow process. And in this non-flow process and in flow process there are further classification which you have to concentrate. That is available in the next page. So let me show you that. Heating and expansion of gases in non-flow process. See, as you know that, as I said, non-flow process is normally taking place in a closed system, and this non-flow process is mainly sub-categorized into two things, that is reversible non-flow process and second one is irreversible non-flow process. So in a reversible non-flow process, what happens? There are around 1, 2, 3, 4, 5, 6 are there. 6 reversible non-flow processes are there. Which are those? Constant volume process. See, this is a constant volume process. It is normally taking place in the closed system. Okay, so it is also called as isochoric process. It is also called as isochoric process. And second one is a constant pressure process. Constant pressure process is also called as isobaric process. And next, hyperbolic process. Okay, so afterwards we can take a constant temperature process. It is also called as isothermal. And next is adiabatic process. It is isentropic process. And next is a polytropic process. And after this, irreversible non-flow processes. Which are those? Which is happening in a free expansion process. Irreversible process is only one where it is not a reversible one. So reversible, if it is a reversible, then we can call these things as a reversible non-flow process. If it is a irreversible process, means definitely it is a free expansion process. Okay, so this is regarding the classification. As I said, according to the syllabus, classification of a non-flow process or classification of a thermodynamic process is very important. Classification of thermodynamic process is mainly two types. First one is a flow process, second one is a non-flow process. And in a non-flow process, reversible non-flow process and irreversible non-flow process. And in reversible non-flow process, constant volume, constant pressure, constant temperature, hyperbolic, adiabatic and polytropic process. And in irreversible process there is only one type, that is called free expansion process. So one more thing I would like to tell you, that constant pressure, how to remember constant pressure process as isobaric process is, see, the unit of pressure is bar. The unit of pressure is bar, BAR. As you know that 1 bar is equals to 10 raised to 5 Newton per meter square. Here you can remember pressure unit is bar, therefore we can take it as isobaric process. And afterwards constant temperature process, how you can remember it as isothermal process? Iso means same, iso means it is a constant. Okay, so thermal, so as I said, the temperature is related to heat, heat means thermal, one and the same, therefore temperature means thermal. So constant temperature process we can remember it as isothermal process. And afterwards volume, so volume means choric, therefore we can take constant means it is iso. Okay, afterwards volume is choric, therefore constant volume process is isochoric process, constant pressure process is isobaric process, and constant temperature process is isothermal process. So in this, according to your syllabus, you have to concentrate on constant volume, constant pressure, isothermal and isentropic process. Only 4 are there. This one, these two and these two are there according to this syllabus. And let me show you the next topic also, which I would like to consider in the next video. So constant volume process or constant pressure, constant temperature, or in adiabatic process, you have to get the relationship, that is 5 relations you have to get. So this is a sketch which is related to the isochoric process. Okay, isochoric or constant volume process. In that you have to get this relationship, that is pressure. See, this is P1 by T1 is equals to P2 by T2. This is the first expression which you have to derive. Okay, this is the first equation which you have to derive, that is pressure volume temperature relationship. Second one is a general expression for work done, and third one is a change in internal energy, and fourth one is a heat supplied or heat transfer, and fifth one is a change in internal enthalpy. So dear students, please remember that he may ask you any one derivation for 5 marks. It can be asked, or this can be asked, or a relationship which is very small he may not ask. But see, expression for heat supplied he may ask that Q1 to 2 is equals to mCV into T2 minus T1. He may ask you change in enthalpy, that is mCp into T2 minus T1. So therefore in the next class I will derive all this. So this, if it is asked like derive an expression for enthalpy in a constant volume process, means you have to derive this. It can be asked for 5 marks. So similarly for a next topic, that is constant pressure process, it is called isobaric process. So it is a related sketch, and then this is expression, pressure volume temperature, work done, and change in internal energy, heat supplied, and last but not the least, that is change in enthalpy. So this is how we have to derive the equation. In the next class I will take all 4 in separate videos, and along with that for each process I will solve 1 or 2 related problems. Okay, so this is regarding today's video. So thank you very much for watching.